Okay, good morning. Welcome to
AwesomeMath number 90.
AwesomeMath number 90. So this morning we started talking about divisibility rules, and you had such a great explanation for the divisibility rules for powers of 2 and powers of 5. I just wanted to have you explain that. So they asked a question. So if you pick a random 4-digit number.
Let's do 5, 5, 3, 4.
5, 5, 3, 4. Okay. They said for 2 to the 1, you only have to look at the last digit. 2 squared, you only have to look at the last 2 digits. 2 cubed, you have to look at the last 3 digits to determine if the number is divisible. By 2, you look at the last digit. By 2 squared, you only need to look at the last 2 digits. For 2 cubed, only the last 3.
2 to the m, you need to look at the last m digits.
Yeah. So, can you give a shot of explaining why that's true? Why, if we're going to try to determine if 5, 5, 3, 4 is divisible by 2, we only need to look at the last digit? Why is that?
If you take 2 and you can multiply it by 5 to get 10, and then anything past the last digit you can make with tens.
Okay, why? Like, how can you make this 3 with tens?
Because you can split it. That's the tens digit. You can say 3 times 10.
Oh.
5 times 100, you can say 5 times 10 times 10.
Okay, great. Great. So that's for 2 to the 1. What about 2 squared, where now they say you have to look at the last 2 digits to determine if it's divisible by 4. Why is that?
Because you can multiply 4, you can multiply it by 25 to get 100.
Okay.
And anything past this point, you can make with 100. So you can make 5 times 100, and then 5 and 100 times 10.
Okay. So 5,000 you already know you can make with 4s.
Yeah.
500 you can make with 4s because you can make 100 with 4s.
So
So
you just have to check these last two.
to check if it's divisible by 4, we only have to look at 34. Interesting.
And then 2 cubed.
2 cubed.
2 cubed is 8. We can multiply it by 5 cubed to get 1,000.
Alright.
Now, anything past this point will be divisible by. It's divisible. You can split it into thousands. This would be 5 times 1,000.
Okay.
And so you just have to check the last 3.
Interesting. Okay. And how does it work in general, then, for 2 to the m?
2 to the m, you can multiply it by 5 to the m to get 10 to the m.
Alright.
And then 10 to the m, there's some number of digits that past a point they will be divisible by 10 to the m.
Okay. Some number of digits.
Yeah.
How many?
Oh, m minus 1 digits.
Well, let's be careful. How many digits did we need to skip over it for 2 to the 1?
We need this, well, 1.
How many digits did we need for 2 squared?
Just 2. So
We skipped over the first 2, and then anything to the left of that was divisible by 4.
it would be m digits.
So for 2 to the m, what you do is you need to skip past the first m digits.
And then you need to,
anything to the left of that.
will be divisible by 10 to the m.
Yeah. So, it's pretty neat, right?
Yeah.
And exactly the same argument works with what other number?
5.
With 5. It's sort of because 2 pairs with 5 to make 10s.
Yeah, you can just flip this around.
Yeah, so exactly the same argument shows that for 5 to the 1, we only need to look at the last digit. 5 squared, we need to look at the last 2 digits. 5 cubed, which is 125, we need to only look at the last 3 digits to tell if it's divisible. Pretty cool.
Yeah.
Pretty cool. Alright, here's a pen cap. High five. Good work this morning, sweetie. Good work.